Now we are in the part 2 of the errors chapter. Since the numerical methods employ an approximations in place of an exact analytical method and are performed in finite precision arithmetics, every numerical computing will introduce errors. These errors may affect the accuracies of the results. Then the questions comes in. How accurate are the approximations that we have made? Thus, understanding the concept of the error is very important so that we can try to minimize them and reduce the computational cost. Perfect accuracy in most numerical computing is impossible. We must aware that several types of errors may exist in the calculations to limit the accuracy of a numerical computations. In particular, we will look at the round-off error, truncations error, and catastrophic cancellations errors that occur in numerical computation. So, what is round-off error? We all notice that there are non-integer numbers such as pi or true that cannot be expressed by a finite number of decimal digits. These numbers are always stored as floating point numbers with a fixed number of bits in a computer. For instance, let's consider the number pi. We may approximate the pi by rounding up the numbers to 5 significant figures as 3.1416. As a consequence, the round-off error arises due to the intrinsic limitations of the finite precision representations of numbers. That is, the round-off errors depends on how many digits are left out. Hence, the magnitude of possible round-off errors can be reduced by increasing the number of decimal digits in the number representation. Usually, once an error is generated, it will propagate through the further computations. Hence, any computations involving the approximated pi will induce further round-off errors in the computing. Many mathematical processes are infinite, such as the exponential series. Unfortunately, no one can perform the mathematical procedures to infinite accuracy. Truncations error is the error resulted from using a truncated finite series to approximate the infinite series. For example, the exponential functions can be approximated by its first 3 terms of its Taylor series. Then the left out term is called the truncations error. Next, catastrophic cancellations errors occur in floating point arithmetics when the subtractions of two large almost equal quantities is subject to severe round-off errors. Loss of precision occurs in this case, where the relative error increases substantially compared to the absolute error. Let's look at one example here. The calculations for z equal to x plus y minus y will return the result 0 in Scilab. However, the true value here is pi indeed. Here, x plus y and y are two almost equal quantities, where x plus y is approximate as y. And hence, z equal to x plus y minus y become y minus y, which returns a result of 0. In fact, the actual answer should be pi instead of 0. As a consequence, we get a 100% relative error in this case.